All right, we are recording. Hi, everyone. My name is Priyank Kalla, and I'm a professor in the Electrical and Computer Engineering Department at the University of Utah. Thanks for joining us. I'm going to give you some information about the computer engineering program. So I have actually prepared a slideshow. I'm going to show you some slides, will give you some information about why you should seriously consider the computer engineering program at the University of Utah. Okay. We also have Professor Armin Tajali joining. His faculty member also. He does circuit design, low power circuits that go in computer systems. And then we also have three of our students, Lindsay, you can say hi, John and Bailey. Um, they are currently enrolled in our computer engineering program, and they will also tell you a little bit about their experience with the program. So let's just start. I'm going to share the screen, and let's run the slideshow. All right. So as I mentioned, my name is Priyank Kalla. I'm the CE program director. So I basically manage the nuts and bolts of the computer engineering degree program. So the agenda today is I'm going to tell you what exactly is computer engineering and what is computer engineering at the University of Utah. Uh, our university has been at the forefront of the computer engineering revolution since the 1960s. We've made a lot of impacts in the development of computer engineering technology as well as education. So I'll tell you about all of that. I'll also basically show you that how our program, it's focused so much on experiential learning that all our students actually do a lot of hands-on projects. Um, so they basically put all the knowledge and theory and technology to practice. So I'll show you some videos that will basically give you a glimpse of all the cool things that our students actually make and learn about computer engineering and design. Okay, and then you can also hear from the experience of Lindsay and John and Bailey and so on, and then we'll conclude with a brief Q&A session. All right, so as I was saying, all intellectual discussions begin with a nice looking video. So this is a marketing video. All right. So let me tell you a little bit about computer engineering, right? So we believe that our role is as computer engineers is to design and build systems, right? We want to have fun in the process of designing, and we want to basically change the world around us for the better, right? And ultimately, what we want to do is build systems that not just work, but they work correctly, they work safely and securely. We need to be mindful of the impact of our work on our environment, the impact on sustainability issues, the impact on society and economics and so on. So in order to do all of that, we need some skills. So of course, we need basic science skills in maths and physics, chemistry, material science, and so on, right? We need to do engineering basically need to do circuit design, architecture design, and how to test the systems that we build, how to program them efficiently, and so on. Engineering is both a science as well as an art. So it's important to show your creativity, right? Your system should look elegant, right? And as well as you can't overlook the sociological aspects of engineering. Like teamwork is very important. Presentation skills. If you work in a team, you have to talk to each other. So technical writing and presentation skills and all those kinds of things. So the University of Utah, our program will basically train you in all of these things, right? So we believe, right, our program basically is, it revolves around design and implementation and testing, verification, programming of computers, and also computer control systems. So we don't just build things, we basically also write not just hardware, but also software, and how to write softwares efficiently, that go on either high performance computing systems or also on embedded systems and so on, right? So computer engineering, our program at the U is basically unique in many aspects. One of them is the fact that it's offered by jointly by two departments. So it's offered by the electrical and computer engineering department, to which I belong. And then there are our colleagues in the computer science department, are also part of the computer engineering program. So there is a committee of faculty members across both departments, and we share courses, we share projects, we share lab space, and jointly administer the program. Okay, so this gives you a lot of diversity of the courses that you can take. They go from hardware, circuit design, to softwares and machine learning and operating systems and so on. Our program is very hands-on and very project-based, and in the end you'll basically make a lot of cool things, right? So here, the sub areas within computer engineering, you can actually, once you have to study some core courses across both electrical engineering and computer science, and then you can take electives which focus in areas of your interest. So you could do circuit and logic design, you can do architectures and embedded systems, you can design CAD tools, you can learn software engineering, artificial intelligence, even biological systems. There are people in our area who actually use computer engineering technology to biological system synthesis and analysis. And then there are other people who are actually researching new semiconductor devices, which basically might actually end up in future computer and computer control systems. So our program, it's a good mix of design and design space exploration and analysis and validation. So when you do a homework, right? If a homework or a project, if you're learning how to design a computer, you'll not just learn on piece of paper, but you'll also implement it on a hardware. So on the top left, you see is a reconfigurable array, field programmable gate array. If you can actually design any computer system and download on this, and actually basically test how it works, right? On the right, what you see is another design that was implemented by a former student of mine. This is basically a circuit which performs addition, but it uses not just electronics, but also light. So this is like an optical computing chip. You see the University of Utah logo. And then we also teach how you can actually look at effects of the environment on your devices, and you can perform analysis. So on the bottom left, you would basically see the same electronic circuit, which is simulated by hotspots. So what would happen when your circuit runs and it heats up? How would its performance degrade? And how would you mitigate that effect? So we basically teach you not just to design, but also analyze and test and validate your systems, right? So quickly, I want to show you something about some information I want to give you about the history of computer engineering at the University of Utah. U of U has been at the forefront of developments in the CE technologies. So one of the first developments was basically on digital recording. So Professor Tom Stockham, he's basically known as the father of digital recording. He was a professor at the University of Utah. He founded a company called SoundStream and basically became one of the first digital sound recording studios. He even won an Emmy and a Grammy nomination for his work, basically. And you guys know in Hollywood, right? Digital sound recording is now is just well understood. So it came out of University of Utah. So did computer graphics. So Professor Raven Sutherland, he was basically the one who really pioneered computer engineering at the University of Utah, and he invented the Sketchpad, which was basically a computer graphics interface, right? He's a recipient of the Turing Award. That's like a Nobel Prize in computer science and engineering. And he's also an advocate for asynchronous design methodology. So University of Utah has also pioneered a specific methodology on how to design circuits, right? there are various startups that actually came out of these sort of technologies. You must have heard of Cirrus Logic, Soundstream. Pixar, of course, is computer graphics, which came out of University of Utah, and so did Silicon Graphics and so on, right? Another interesting development that it psychs me out all the time is that is the ARPANET. So we all know about internet. We are using it right now, right? The precursor to current internet was basically called ARPANET, right? And it turns out that people knew they had these ideas on how to connect computers on a network. So this was basically funded by the federal government, and in 1969, it basically ARPANET became functional, and there were 4 nodes. Okay, this was probably one of the largest networks, the first network, and University of Utah, you can actually see, was part of the 4 nodes that were connected. So they were from University of California, Santa Barbara, UCLA, SRI, which is Stanford Research Institute, and University of Utah. So we actually had designed interface messaging processors, which were basically like routers, right? And they were connected to local computers, and people were sending messages across. And you would see IBM 360 was a commercial machine which UCSB used. But look at University of Utah. We used PDP-10, which we made not just the first sort of choices, but we also made the correct choices in using this type of the right kind of machines. Okay, that's a hand-drawn design. It's actually, I borrowed it from a former University of Utah professor, and the origin of this basically figure is actually, I think, from 1969. The University of Utah has also been at the center of CE education. So today we teach microelectronic circuit design using a particular technology that we call VLSI technology. And VLSI technology, as soon as it became available, we've been teaching it. We were one of the first of 4 universities, right? So MIT, Berkeley, Caltech, they basically initially offered courses in this area. And they were basically, experimental courses initially.
Last night I was all about like
right.
earthquakes
So,
and like stuff.
And then what happened was Professor Kent Smith at the University of Utah was also teaching the same course. Right. And then what I will do is, just give me a second.
Yeah, I picked the 3. I thought these ones would be interesting, and they've been mixed back. The first one was interesting.
Hey, could you make sure that your mics are muted, please?
I've actually kind of done that kind of stuff in school.
Logan, you're not muted. Please mute yourself.
I'll mute it. I'm muted. All right. So what I'm going to do now is show you a video. Just take a look at this video, and then I'm going to talk a little bit about it. So what you see here is a design that was actually built by a team of 4 senior students. So when you go through your degree, in the final year of your degree, you have to actually build a senior capstone design project. So this particular team came up with an idea of solving the Rubik's Cube automatically. So what had happened was this was a couple of years ago. They came across, there was a news item that somebody had actually established a world record in solving the Rubik's Cube in 7 or 8 seconds or something like that. So these guys thought, can we not try to break that record if we automate the entire process? So what they did was they came up with this idea that they'll build a machine like this, and there are 6 cameras, okay, that are taking pictures of the Rubik's Cube. Then they do some copy that image onto a computer, and on that image they run an algorithm that basically solves the Rubik's Cube, right? And then at every step they basically make a move, and that's the moves that you're seeing. So through their computer, the moves are then sent as signals to some of the some of these servo motors, and they moved to basically solve this Rubik's Cube, right? It actually took them around 25 seconds to solve it, so they were not able to defeat the world record. But it's a very good demonstration of their skills, and it's a combination of skills that they're doing hardware design, they're basically doing image processing, they're basically building algorithms, and then they're also able to put their ideas to practice, things like that. So what I'll also do is show you some other project. Let me skip this one. In the interest of time, I'll show you a junior project. So the previous project that I showed you was done by senior students, but our entire program is basically very hands-on from the start. So these are some of the students who are not seniors yet. They are juniors. They're in my class, which is like a computer design lab. So just hear what they have to say, okay? Look at their ongoing project.
Hello everyone, we are students in the University of Utah. We're in the Computer Design Lab course, and what we have here is a Pac-Man game put onto a computer that we designed ourselves. And so as you can see, we can change Pac-Man's direction. That's at the point of where we're at in this lab right now. And so I'm using this Xbox controller, and we can press the buttons on it and move Pac-Man's direction. Obviously it's not done yet, you'll be able to move around later. The way that we have this working is that we have this Xbox controller connected to a Raspberry Pi, and then the Raspberry Pi is connected to the FPGA. And that just makes things a little bit easier for us on our end to use the Xbox controller. It's a little hard to use an Xbox controller, but as you can see, it works pretty well. I'm changing these numbers by pressing the buttons on the Xbox controller. And then these LEDs back here are little flags. And that is just sent by the CPU that we put into this FPGA here. And so what we have on the FPGA is this schematic where we actually designed a CPU. And so this is just a pretty simple schematic. It doesn't look too simple, but overall it does actually simplify a lot of what's going on. But these are things that you'd get to understand if you attend this class. A lot of this, personally, as a student here, I've been working on this type of stuff for just under a year. I didn't understand any of it, but I promise that anyone who takes this course will be able to understand everything that's going on here and have a lot of fun doing it. And in the end, you get to bond with some really awesome students as well and have a fun time just enjoying working with hardware and software at the same time.
Yeah, so this is a class which is a lab-oriented class. In this class, students have to design a full-blown RISC microprocessor from scratch. They have to interface it with I/O devices, and they have to design their interfaces once again from scratch. They also have to interface it with VGA. So it's not just buying a VGA monitor and hooking it up. What are you displaying on, and how do you display it? So there's a lot of engineering that goes in there. The entire VGA controller module has to be designed from scratch. And then they have to write their own assembler or like a compiler, and then write their own software on it. So this is like and they do it as a team of 3 or 4 students in one semester. So the project is still going on because there are still a couple more weeks remaining for them to finish their project, okay? So why don't I stop sharing the screen for a minute, and I'd like you guys to hear from some of our students. So Lindsay, you want to take over and tell these guys about your experience in the program?
Sure. Hi, my name is Lindsay, and I'm going to go ahead and share my screen. I've made a PowerPoint for this. So can you see my screen all right? Alrighty. So I actually have another degree. I graduated with a degree in psychology, and I started in computer science, but I ended up in psychology. And I realized I wanted to go back to school, but CS wasn't quite right. It was missing something, and I always felt that. So I wasn't sure what that was until I started looking into computer engineering, and I realized it's the fact that computer engineering gives you the full scale approach. You get a lot of implementation understanding from the hardware side and the software side. And when you can understand both, it gives you so many more opportunities, especially since computers are in everything and you can choose which side you want to focus on. But having that full scale understanding was something that was missing in computer science, but computer engineering gives you. So I decided to focus on computer engineering, and the computer engineering at the U is one of the best decisions that I've ever made because you get hands-on experience from the get-go. You get to do a lot of work with your labs and projects. And these kinds of labs and projects actually prepare you for research opportunities and also just working in the field later on. And the coolest thing is that you get started with this stuff right away. So you can get involved in research opportunities early on, and you don't have to wait until your junior year or senior year to get involved with these things. So actually, I'm not quite a junior yet. I'm getting closer, but I am already in a 9-month-long research project that is completely paid for the entire time. And just the fact that my labs and projects have prepared me for this is really cool. There's so many research opportunities. They're super flexible for you as students because they understand that you are a student and you have classes, but they also give you a lot of opportunities to work and make connections for internships, for jobs. There's just a lot of support for you. And you also have scholarship opportunities, and your professors really do want you to succeed. So with all of this, when you start your degree in computer engineering, you're pretty much just getting ready for your job from the get-go. And you'll probably already get a job before you even graduate because you get so much experience and you can take it and apply it to what you're doing. So currently I'm on this research project and we're looking at how we can make what's called an Internet of Things sensor network system using wireless transmission to collect data and gather information from the world around us without actually having to be there and understand what's going on. So this project is using microphones and accelerometers, but you can take these things, and this is a project that is both hardware and software. And being a computer engineer, you can do both, and you can design this whole system from start to finish and understand what's happening. And that's something I love about computer engineering, is that you get the flexibility to understand both sides of things and implement them. But also when you get to do research, you get to go out and take what you've learned in the classroom in the labs and actually apply it. So you can go into the field with things, you can test things on site, you get out of the classroom and kind of see how what you've learned applies to the real world. And that's something that's really rewarding. Also, this kind of stuff translates directly to jobs or directly to your own startup. So there's a lot of opportunity for you to build something while you're already a student into something that could be your future career. And that's something that the U really does very well by giving you so many opportunities to work on hands-on projects from the get-go. You're always working on really cool labs, and there's a lot of freedom to what you're doing with your projects as well, so that you can do things that are interesting to you while you're learning on the way. And it's a really great experience. I definitely recommend computer engineering at the University of Utah for that reason. So if you want to learn a little bit more about the research I'm doing or how to get involved, or if you just have any questions, I'll be involved in the advising session that's after this later, and there's going to be some more information on that to come. But you should definitely check out computer engineering at the U and get involved.
Thank you.
Great.
John, you want to take over?
Yeah, I'm going to quickly share my screen here. So like Dr. Kalla said, my name is John. I am currently a senior at the University of Utah, and I wanted to go over pretty quickly a little bit about our senior project. To give a little bit of context, at the beginning of this year, we were able to select our senior project teams. And then we came up with a project idea that we just had to present to the faculty members in order to get it approved. And the problem that my team came up with that we wanted to solve was being able to communicate, like text other people, even if you don't have cell reception. So here is a prototype device of what we have designed, just to kind of give you a sense of like some of the different interesting hardware choices people can make. But ultimately with this device, there are 4 main components, one of them being a Bluetooth radio, one of them being a long range radio, a little computer chip, and then also like the battery power management chip. And with this project, we were able to know how to interface all 4 of those components and also design our own phone application. So our phone application is able to connect over Bluetooth with our device. And over here on the right side of my screen, I'm showing the screen of a device that I'm using as the recipient, but I don't know how to do 2 screens at the same time on my computer. So I'm just gonna have to kind of show you this. So I have one phone that I have like a how's it going message, and then I'll send that message. And then after a second, you can see on the recipient, it shows this how's it going message. And I wanted to show that just as a demonstration to the amount of skill that getting the computer engineering degree from the University of Utah is able to give you. Because this was a really fun project that we just chose that we wanted to do for our senior project. We saw a problem, and that was that we couldn't communicate with our friends. A couple of us on our team like to do backcountry skiing or mountain biking, different adventuring things outdoors in places that you don't have cell service. And this is even an industry that there aren't actual established products. There aren't companies that have actually developed products like these. But for us as students at the University of Utah, we've been able to gain those skills in a quick enough time that we're actually able to build a prototype of a product that we could pretty legitimately take to market and like sell it if we actually wanted to. And that's something that's a really big advantage of the University of Utah is the preparation that you get, the skills. I never thought that I would be this far by this point already. I was actually able to get internships before my junior year, and my internship this previous year actually led to a full-time job offer, which is even more of a big deal right now during the pandemic because a lot of places are doing hiring freezes. But because of the skill set, and I'm not even graduated yet, but I was able to get a full-time job offer. So computer engineering gives you really good skills. It gives you the opportunity to work on really cool projects through these courses that are actually projects that you come up with and just argue your case why they should fulfill the requirements, and then you get to build some cool stuff that actually makes an impact.
All right, thank you, John. It's great to hear from all of you. I'm just going to show you a couple of other things that, our students, they get around, once you get your degree from here, our degree is very well recognized. So our students work not just in Utah, not just in the Salt Lake Valley, but they go all over the place. It's a very satisfactory, career that will give you a lot of job satisfaction. And also, if you consider average starting salary of U of U grads, right, computer engineering grads, and compare it with the average starting salary of graduates from other departments, other degree programs, you'll see that computer engineering pays you very healthy salaries. Okay. And it's not just about salaries. It's basically about if you like what you do, right, computer engineering will give you a lot of job satisfaction, and there's going to be a lot of different opportunities. It's a very diverse field, and you can find your interest. Whatever you want to do, it'll give you, you can basically do it in computer engineering. All right. Before I close, I just wanted to let you know that there's going to be an advising session starting right about now in 5 minutes. William Turner, who's our CE academic advisor, he is going to, he can answer all your questions. There is a Zoom ID and passcode. It's also copied and pasted on the chat. So if you have any particular questions regarding, the nitty-gritty details of the program, William can answer. More high-level questions, feel free to ask any questions that you may have. We still have a couple of minutes, and we can try to, give you more information. So it's few of us here online, so just feel free to go ahead. Oh, did I not share my slides?
No.
Uh-oh. Did I make that mistake? I make that mistake all the time. Anyway, so I was basically showing you that, our students, they get job offers all over the place. Okay. I was also meaning to show you this particular slide that will, give you some idea about starting salary of U of U grads. This is some data which was compiled 2 years ago. Okay, so obviously this data has gone up. And then this is the picture of Mr. William Turner. He's our CE academic advisor. If you have any questions, there's going to be a Zoom session. Otherwise, I'm going to stop sharing, and please feel free to ask any questions you may have.
We can answer questions from the chat as well if you just want to type them.
Yeah, if you just want to type them. I'm going to stop recording.